Okay, so today we're going to start something that's called stoichiometry. Kind of a weird word, but this is about we'll say chemical equivalency. So first there are some terms we have to talk about. We're going to review mole because we did it really quickly last time and I just said the word, we didn't talk a lot about it. A mole is represented for each chemical element, let's say on the periodic table by its box. So you can find out a lot of information about that box or square. Each of those squares for an element tells you, what do we call that when we go on there and we get that average atomic mass and we add it together? What have we been calling that? The first thing we started with, the simplest thing, before we did percent composition. What were we finding? Yeah, molar mass. So each one of those squares tells you molar mass for the element. So we can call that, off of the periodic table, if we round it, we call it mass number. If we're using it to calculate parts of a compound, we call it molar mass. We can also call it average atomic mass because it's the average of all the weighted isotopes. So really that means three different things. You should know those three different things. So look at your periodic table and find, let's see, find mercury. And I'm going to circle it. So when I look at just that square, it represents 1 mole. Also looking at that square, I can say its molar mass is 200.6. I can say its average atomic weight is 200.59. I can say the mass of 1 mole is 200.59. So I can take all that one number and that one square and I can figure all of those things out. So take a minute and find iron. Let's find Fe, and I want you to find molar mass, average atomic mass, the mass of 1 mole. Did you find it? What should be true about all three of those numbers? What you think, Carly? What should be true about all three of those numbers? They're the same. Exactly. For all three of them, you probably wrote something like 55.9. Yeah? And that's grams. And if I'm talking about molar mass, it's grams per mole. So you have to pay attention to what the question is as to what your units are. Grams are always going to be there. Mole only is put there when you're talking about molar mass. Okay. So, as we're working with this stuff, each square or box on the periodic table when you look at that periodic table, each box or square on the periodic table represents the same number of atoms of that element. And that's called, because this is the guy who discovered it, Avogadro's number. He did all kinds of experimentation with carbon when they were setting up the periodic table, the most modern one, or where our modern one is based on, and he figured out how many atoms were in 12 grams of carbon, and then he figured everything out from there. And we're not going to go into all those details. But Avogadro's number is the number of atoms in 1 mole of any substance. And it's the same for all substances. And it looks like this. 6.02 times 10 to the 23rd atoms in 1 mole. That is a really important number. You need to memorize that. So grab your periodic table again. Are you done with this page? Can I flip it? Let me wait a minute. And then grab your periodic table, and I want you to find these 3 elements. We'll do silicon, radium, and xenon. I'm going to do this. I want you to give me the molar mass, and I want you to give me the number of atoms it represents for each of those 3. See if you can do that. Yes? Oh, sure. Hold on, guys. I'll flip back for a minute. Good? All right, so find these 3. I want to know their molar mass, which is the number of grams in 1 mole. I don't know if I told you that before, but the abbreviation for mole is MOL. It's not much of an abbreviation. Go from 4 letters to 3. Okay, so who's got the molar mass for silicon? Everybody should. Carly, what do you have? Okay, she said 28.1. What did you tell me about the number of atoms represented? Yeah, 6.02 times 10 to the 23rd. Kalia, what is the molar mass of radium? 226.1. Is that what you said? Okay. How many atoms does it represent? Yep. And Caleb, what'd you put down for xenon? 131.3. How about number of atoms? See what's happening here? They're all the same, right? This is a big, big thing to remember. The only time you use a different number of atoms is if it's given in the problem. Always, within the problem, you will use 6.02 times 10 to the 23rd unless the problem starts by telling you you have 3 times 10 to the 28th atoms of. That is the only time you won't use this number when we work these problems. Okay, so really quick, let's write these definitions. A mole equals the quantity of matter in grams that contains 6.02 times 10 to the 23rd atoms. Avogadro's number equals the number of atoms in 1 mole of any substance. And molar mass, so you've got a good definition, equals the quantity of matter in 1 mole of any substance. Any questions about those 3 things before I show you a little bit of math with them? Okay. Good to flip? All right. So we can have, basically there are 3 types. One includes moles and grams. One includes moles, or two I should say, moles and atoms. And the third type includes, we'll say, grams and atoms. So when I have grams and atoms, the problem is either going to ask you to go, moles and grams. The problem is either going to ask you to go from moles to grams or from grams to moles. So that can look two different ways. I want you to think of this as a two-step problem. It's one of the easier ones. So 2 steps. Moles to grams or grams back to moles. Anytime you have a problem like that, it's only going to take you 2 steps to solve it. So let's look at one of those. 3.5, we'll do the moles of, I said that earlier, KCl is equal to how many grams? So the first thing we do, this is like you may have done this in math before. It's called dimensional analysis. And there's a way that you need to set these up because as they get longer and longer and longer, it'll keep your information clear. So I start this by making, it's a 2-step problem, so I just make a set of boxes that looks like that. This first box, this is really important. This first box never gets anything in it except for what you're given. So look in your problem for what you're given. 3.5 moles KCl, and it goes, whoops, put my L on, it goes right there, always. And treat it like it's over 1. And then I look at my units right here, mole, and I know that those are the units that I want down below because they have to cancel each other out. The only number you will ever use in canceling out moles is 1 because all of these things are based upon 1 mole. So if you're given 3.5, it's okay, it goes here. But anytime you're working through these problems and you're trying to cancel out moles, the 1 mole goes below. What do I want my final answer to be in? Grams. So I want grams, KCl up here. Where do I go to find out how many grams are in 1 mole? Ooh. Where do I go to find out how many grams are in 1 mole? Anybody want to take a shot at it? Mara? Yeah, I go to the periodic table. So we're going to go to the periodic table. Essentially, we're going to calculate this molar mass. I'm going to find K, and I'm going to find Cl. And I only have 1 of each of them. And I think Cl is 35.5, and I don't remember potassium. Check that, make sure I'm right. Yeah. And potassium is 39, yes? So then I just add those together. 74.5 grams, is that right? You punch it in, somebody. Yeah? All right. So then I put my molar mass, 74.5 grams up here, and this is how you work through these. If it's above this line, it means you're multiplying. If it's below this line, it means you're dividing by it. So when I put this into my calculator, I would have 3.5 times 74.5, essentially divided by 1. So it's really just a multiplication problem. You have to show these things because you have to show how they cancel out. Does that make sense? Punch that in your calculator and see what the answer is. I don't know where mine is. You got it, Faith?
Yeah.
Round it to the tenths place for me.
Okay.
Now tell me the answer.
260.8.
260.8 grams KCl in 3.5 mole. What do you think? Easy? All right, so let's do the flip side of it. Let me ask you, how many mole are in 412 grams of, this time we'll use sodium chloride, NaCl. See if you can set that up. This is another two-step problem. Shoot. Before you go too far, what's going to go in the first box? Yeah, what you're given always goes in the first box. 412 grams NaCl. Then ask yourself, what do I have to get to cancel out? Raise your hand if you need help setting it up. Ooh, you're smart kiddos. Okay, so let's talk about this. Grams are here, so I have to cancel out grams. So I have to put grams NaCl here. And what do I want to know about? What has to go in this top box? Where do I want my units to end up? Moles, good. So this has to be moles. Oh, shoot. Moles NaCl. So down here, remember we could only ever use 1 for moles. And down here, I didn't add it up yet, should be your molar mass. Yeah? So let me tell you, I need you to pick up one of these papers.